Hello, welcome once again to our science lesson, and our topic has been biotic environment, but we are looking at biotic relationships in the environment that can affect distribution of living organisms. We have just discussed parasitism, and we have said parasitism is where we have two organisms, one called the predator, the parasite that is, relating with another organism called the host. And in this relationship, the parasite is the one that benefits from the host, but the host in the process is going to be harmed. In other words, it loses benefits like nutrients and sometimes receiving disease microorganisms or pathogens. So we were to look at some of the ways in which parasites and hosts adapt to their ecosystem, because we have always stated that there must be a balance between the parasite and the host. Otherwise, if all the hosts are cleared, parasite will follow the suit, and in the process they are also going to be eliminated from the ecosystem. That is why the parasite and the host must be able to produce adaptations for them to be able to survive. So we want to look at this table, complete the table. Complete the table below. We have the parasite, we have adaptations of the parasites, and then the other column is showing host, suitable host. So with the kind of adaptation each parasite will produce, what type of host will be best for the parasite? So one of them is the flea. Now, here we are going to include some photos, but for now we shall discuss, then you'll also look at the photos of the flea and the rest of the parasites, so that you can easily be able to connect with the adaptations. So one of the adaptations of the flea is that it has a flat body, small and flat body. Having a flat body is important so that it cannot be easily seen, not very visible or easily visible. So if it cannot be easily seen by the host, then it can easily manifest itself or be able to live on the body of the host. At the same time, having a flat body will enable it move within the hairs of the animal, easily move. In fur or hairs of the host's body. So fur is equivalent to hairs. Fur is that hairs that covers the skin of mammals. We call it fur, or we can refer to it as simply as hairs. The other feature of the flea, the hind limbs are usually long hind limbs. Long hind limbs. Having long hind limbs is important because it's going to enable the flea to jump easily, on the host with a lot of ease, Then the other parts that we can easily get from the photos, the mouth parts. It has mouth parts that are specialized for biting and sucking. Specialized for biting and sucking. So it's going to bite and suck blood from the host, and in the process be able to obtain the nutrients that it deserves. So suitable host, mainly those animals that have hairs, because if it is a smooth animal, it is not going to be able to form a good habitat for the flea. So most mammals, especially terrestrial mammals, when we talk of terrestrial, is the same as land. We have mammals in water. We cannot have fleas living on the body of animals that are in water, because most of them even lack hairs, and at the same time it does not form a good environment or habitat for the flea. So mammals will form very good habitat or very good parasite, a host for the parasite flea. So mammals like dogs, sheep, even cows and the rest that have a lot of fur on their bodies. Other animals that are good hosts or that form a host for the flea are the birds, having feathers on either body. It forms a good habitat for the flea. So these are some of the structures that will enable a flea be able to survive or become a parasite toward or on this host, the mammals and the birds. We can look at another parasite, tapeworm. So the tapeworm. Remember the other name of the tapeworm, we said it is in the genus Echinococcus granulosus. But if you can't get that name, just mentioning tapeworm is enough. So some of the adaptation of tapeworm include having suckers and hooks. The suckers and the hooks are important. They're found in the head region of the tapeworm. They're important for attachment, especially for the hooks, attachment onto the host, to attachment on the walls of gut of the host, or the gut walls of the host, because of the hooks. Suckers are important again because remember, the tapeworm is living inside the host to obtain nutrients. There are two venues to obtain nutrients, one through sucking of blood. So the suckers comes in, and sometimes through diffusion through the body surface. So suckers to suck blood, sucks blood to obtain nutrients. Other important features include having a flat body. Tapeworm has a flat body. Having a flat body increases surface area for absorption of digested food materials. To increase surface area. to increase surface area for absorption of digested materials from the gut. That's why I've said there are two venues for obtaining nutrients: through sucking of blood, and then also through the flat body surface, where material that have been digested, now that it lives in the digestive tract, is going to absorb the materials and be able to obtain nutrients. Other features include having mucus layer. Tapeworm has mucus layer. This is important to protect it from being digested by enzymes that are found in the digestive system. Protection against digestion, or from, not the best word will be from, digestion by enzymes found in the gut. Now, another feature of the gut is that apart from having enzymes that would have digested the tapeworm, hence having mucus, is that there is less supply of oxygen in the digestive system as in that tube. So again, the tapeworm must be able to adapt to that by having tissues that are tolerant to low oxygen supply. Tissues with low tolerance, with high tolerance, not low, with high tolerance to low oxygen supply, to low oxygen supply, or limited. So because of this, it can be able to survive these features. It can be able to survive in the digestive tract without being destroyed. So most common hosts of the tapeworm include most of the mammals, include man, include sheep, and the pigs. Now, from our life cycle of tapeworm, you realize that we also have the very most important host, the dog, which forms the primary host. But these three are intermediate hosts. The role of intermediate host is just to act as a place for breeding before now it's able to get into their primary host. The other parasite that's common is the tick. Tick. Adaptation of the tick include having small flat body. This is important so that it can easily move within the fur. Within the hairs or fur. So we have said fur and hairs are just equivalent. The other adaptation, at the end of each limb, we have claws. Has claws at the end. Of each limb. This is important so that it can grab onto the host. To grab onto the host skin. Again, is about the feeding, the mouth parts. Specialized has mouth parts, specialized for biting, after biting, sucking blood, for biting and sucking blood. Suitable hosts include cattle, sheep, goat, even dogs. They form a suitable host for the tick. The other parasite is the liver fluke, for liver fluke. So from the photos, you will see that the liver fluke has a flat body, This is important so that it can easily squeeze itself. The word liver means it is one of the organs where it will be found is in the liver. So for it to squeeze into the ducts, the bile ducts, so that it reaches the liver, it must be having a body that is suitable for that. The flat body has a flat body to easily move in the bile ducts to the liver. And then also in the liver we have spaces called the lobes or lobules. So again, for purpose of squeezing itself in these lobules. Again, the mouth parts are suckers, for attachment. For attachment onto organs of the host. Remember, the liver fluke can move from the liver to the lungs. So before it's able to manifest and establish itself, it will have to attach on the walls of the digestive system, in the lungs and also in the liver. The other adaptations include having cuticle. A cuticle. Cuticle is important because it protects it, for protection against or from the immune system of the host. So liver fluke being a foreign material in the body, it is going to be recognized as an antigen. It's a foreign material. Therefore, immune system may come in handy to destroy it, but it's never destroyed because of a cuticle. Cuticle is a tough covering of the liver fluke. The other structure or feature is that the liver fluke is hermaphrodite. Hermaphrodite. Maybe it's the first time or you have come across this term. Hermaphrodite means an organism having both male and female organs on the same individual. So we are having male and female organs on same individual. So having this feature is important because it can reproduce in whichever organ, whether it's in the digestive system or in the liver or in the lungs, without actually requiring an opposite sex. So it becomes very easy for it to reproduce at a faster rate, hence easily reproduces without requiring opposite sex. Requiring opposite sex. So most of the hosts are in the group of mammals. Mammals form the best host or suitable host for the liver fluke. So we have a host of them: man, sheep, cow, goats, and several others. So that was as far as parasitism is concerned. So let us look at another type of relationship called competition, number 3. Competition. Now you have come across the word competition. Maybe if you're competing, if we have 2 teams, they can compete against each other. But again, in the natural ecosystem, in an ecosystem, like in a forest, in a wild, in a game park, there is competition. So the question is, why is it that organisms compete? And when do they compete? So organisms can compete when resources are there, but they are in limited supply. But again, even if they are in limited supply, they must be within the same ecosystem. So the conditions for competition is having demand for the same resources, but those resources are in limited supply, but within the same ecosystem. That is when competition sets in. So when you talk of competition, is when or where 2 or more organisms, 2 or more organisms, there could be many, of same or different species, demand, they need, require, demand for the same resources, but if they're in plenty, there will be no competition. Therefore, it means same resources that are in limited supply, within the same ecosystem, So we have very important features of our definition that we must not forget. There is demand. Demand could be need. You can also say need. Requirement. They are requiring resources. We are going to look at different types of resources that are similar. But condition, the resources are not enough. They are in limited supply, but within the same ecosystem. If they are in different ecosystem, if we have maybe ecosystem A and ecosystem B, and resources in each are not enough, but we have very few here, maybe 1 organism and several here, they want the same resources. In A, there will be no competition. It's the same resources, but they are not in the same ecosystem. So it must be within the same ecosystem. So examples of resources include for plants, A, for plants. Now wherever you are, you can be able to mention together some of the requirements of plants. For for growth or for their survival. Those are the resources that we are talking about. So from wherever you are, I know you can be able to tell me that plants require water. Water is an example of a resource that will be competed for. Minerals. Minerals are also resources that the plant requires for proper growth. We have space. Plants require enough space for proper functioning. It also requires sunlight or light. Light. We have resources like pollinating agents. Pollinating agents. They are going to compete for such resources. Then for animals, they are also varied depending on the ecosystem. We can have water, very important for both plants and animals. They also compete for food. Animals compete for food. They compete for space. That's why we have animals in the wild marking their territories where they are supposed to live. You also have competition for mates. Mates, opposite sex. This is very common. Again, males will compete for females in an ecosystem. And then we have also breeding sites. Breeding sites. Breeding sites. So organisms will compete for several of those resources in an effort to enable them survive in the ecosystem. So these are some of the resources. But as they compete for these resources, both plants and animals, we realize that some are able to compete better. Others cannot be able to compete. So in the process, the one that is successful in producing the best competitive abilities will be able to survive. But the one that is unfit, that cannot be able to compete properly, or it's weak, it usually perishes. It gets extinct with time. We are going to look at some of the examples where extinction comes in due to competition. Therefore, competition is a very important phenomenon in an ecosystem because it is the one that will determine the kind of organism that will survive. That's why we have quotes like survival for the fittest. The most fit organism, the one that can compete favorably, the one that has the best chemistry, is able to survive the competitive age. So we are noting that those organisms that are successful in competing, organisms with successful features for competition, usually survive to reproduce, and in the process, you realize that the number of those organisms with successful competitive abilities increases, thus increase in their population. That's why this type of organisms are called the most fit organism. They struggle to exist. Both organisms should be given an opportunity to struggle, but the one that will produce the best survival tactics, the best survival features, the one that can successfully compete with successful features, is the one that will survive, reproducing. Hence, there will be an increase in their population. But vice versa will happen to those weak organisms with what we call disadvantageous variation, those variations that cannot help them. So those organisms that are weak, in other words, those with unsuccessful competitive features, do not survive. So because they are not surviving, it means that the lineage of such organisms usually disappears from the surface of the earth. They perish completely. That perishing can also be equated to extinction. They get extinct. Extinction is disappearance completely from the surface of the earth. We have had examples of organisms that were there. They were thriving in large numbers, but due to some changes in the environment, they got extinct, like the dionysias, the dinos, or the dinosaurs. So competition is a very important factor that drives several other factors in the ecosystem. We look at types of competition. Competition can be put into or categorized into two, depending on whether the competition is between members of the same species or if it is between members of different species. So for that purpose, we have two types of competition. One of them is called interspecific competition. Interspecific competition. Interspecific competition is competition between members of different species. So if you are going to have competition between individuals of different species, that is called interspecific competition. Man could be competing with birds for maybe space, or with plants for space. We have seen that, whereby man is clearing forested areas for purposes of development, like road development, housing. You are competing. Actually, man is competing with the plants. But because he has better competitive skills, he's able to clear the plants and even lead to extinction of some. But in our case, we are going to look at one of the most widely studied example to explain interspecific competition. So if competition is between members of different species, it is called interspecific competition. Now, one widely demonstrated experiment is that experiment of the genus Paramecium. So in this experiment, we have two types, the two species of Paramecium. We have the Chordatum species, it's a small c, because it's a species name, and Paramecium aurelia. So the two species can be able to survive separately in their own cultures without a problem. They'll grow normally. But when they are put together in the same culture, there becomes a problem. So in one of the experiments, in experiment 1, the two species, Paramecium caudatum and Aurelia, were cultured separately in different media. So the two species cultured separately. In two different media. So if we have this plate A and another plate B, so here you put here Paramecium caudatum, you allow it to grow with the same environmental requirements, and then you put here Paramecium aurelia, then you allow it to grow. The kind of graph that the two will produce is nearly the same. If on this axis you have population, and then here time. Now, because it takes less few days or less amount of time to grow or reproduce, this time could be in days. It will produce a normal growth curve for the two normal growth curves. So, normal growth curve where at first there is low rate of growth. Low rate of growth, we call that one lag phase. Lag phase. Let me have a large diagram of the same. So I'm saying if the two are placed in different media and you tabulate the results of population versus time in days, the two will grow normally just like any other organism, having a lag phase, a log phase, then it now goes to a plateau phase, like that. The two graphs, one will be lower and the other one will be higher. But now we have two species. I want to ask a question on this. We have Paramecium caudatum and Paramecium aurelia. But for aurelia, it has high growth rate, and caudatum has low growth rate. In other words, they produce by binary fission, yes, but one of them will reproduce faster, but the other one will reproduce slowly. So this one has high reproductive rate, low reproductive rate. We have two curves here. Of these two curves, which one do you think is representing caudatum and the one that's representing aurelia? Which one of them? So we have said, you look at the Q there is high and low reproductive rates. So to find that, you pick time. Maybe let us assume that that time is day 2 or 3, and then you find out. You just draw a line, vertical line, cutting through the two curves. Then you assume that there is a population there, you read that value the same time, and then you read that value the same time. Obvious, this value from this curve will be the lowest. It's the same time, but it's the lowest. So that value of the lowest represents that one with the lowest reproductive ability or potential. So that one becomes caudatum. Let us put their values. Suppose the population here is 25 colonies of the same. Then here it is 68 colonies of an organism there. But one, we have said is high, has high reproductive ability, and then the other one has low. So 25 will represent that one of low. So this curve here will be representing one of this paramecium that has low reproductive potential. So this one becomes for paramecium. Paramecium caudatum or caudatum. So the lower curve is for paramecium caudatum because it has low reproductive potential. But this curve, that one now becomes for paramecium aurelia because of high reproductive potential. So they were in different cultures, and the curve is drawn just on the same axis. We could have drawn the two separately. They'll produce the same. But now, to compare their growth rate, it's good that you draw on the same axis. So from this, we have seen that paramecium caudatum, having a lower reproductive potential, will have a curve that is lower than that one of paramecium aurelia. This is when they are drawn separately. Now, a second experiment of the same was this. The two species were grown in the same culture, plated on this culture, the two of them here, and on this, all the requirements for growth were provided, with all the requirements for growth being provided. There was an observation where the colonies of one of them, caudatum or aurelia, I want you to tell me which one, started declining in number. There was a rise and then a fall, but the other one continued to grow throughout. So when those results are tabulated on an axis or a table, this is what it produced. We had this just on the same axis, population density of the two, same culture, time in days. This is what it produced. Obvious, population cannot begin from zero, so your curve cannot begin from the 0 point. It should begin slightly above because we must have organisms that will reproduce. Otherwise, you are not going to, if it begins from 0, then there will be no organisms to reproduce, no parents. So that is 0, so it should begin slightly above. So when this happened, there was no more growth for that, and it continued increasing. But there was one that, I'll use dotted lines, that grew with time, slightly for some time, increased in population, but now it dropped. It dropped until it touches the x-axis. So tell me the meaning of touching the x-axis. But before you go there, we have one that is having high reproductive rate, the other one that is having low reproductive rate, caudatum and aurelia. So among these two, we have two curves, curve A and B. So which one among these two curves, A and B, which one represents paramecium caudatum, and which one is illustrating Paramecium aurelia. So our answer is in the high and low reproductive ability. The one that is able to reproduce faster is the one that has better features or better structures for competition. Because as much as some of the organisms or offsprings might die, but more will reproduce to replace the one that maybe died. So for A, curve A now represent Paramecium aurelia, P aurelia. Why? Because of high reproductive ability. Then B is Paramecium caudatum or caudatum. Caudatum, Paramecium caudatum. Remember the scientific names you underline as you write. If you are using your freehand, you underline. The first name being a genus should begin with a capital letter, but the rest of the letters in the name are written in small letters. So this is a curve for the two in the same culture, showing that the two were introduced in a culture, they demanded for the same resources, competition happened. The result of competition, the one that had better competitive features increased in population and maintained its population, but the one that had poor competitive ability, the weak one, the unsuccessful one, the one that produced a non-beneficial variation, the Paramecium caudatum, increased slightly, but again it dropped until it touches the point, the x-axis. So if we had maybe 20 colonies or 5 colonies of Paramecium caudatum, at the end of the experiment, it is now reading 0. All of them are dead. They have perished, all of them. So it means it has been removed completely from that ecosystem. When an organism is completely removed from an ecosystem, we call it extinction. So touching that point on x-axis means it has undergone extinction. So because of that, then we call this type of competition, it is called exclusive competition. Exclusive competition. It completely excludes, causes the other organism of different species to be completely eliminated from that ecosystem. So that principle or that phenomena where one organism completely outcompetes the other such that it gets extinct is called exclusive competition. So this phenomenon where one species completely outcompetes or completely excludes the other species from the other species, from an ecosystem is called exclusive competition. So we are saying it's exclusive competition because the other organism is going to, or the other species is going to get extinct. The other species the other species gets extinct due to or as a result of competition. As a result of competition. So some of the organisms that disappeared completely from the surface of the earth, this is one of the factor, competition. They could not produce features that could enable them compete favorably. So one reason why competition becomes stiff is competition that is between different species. And again, if competition is within the same ecological niches, if organisms share ecological niche, then there will be stiff competition leading to exclusive competition. So I'm just pointing out very important concept here that if species are of different kind and if they are in the same ecological niche, then it's going to lead to stiff competition, which now leads to exclusive competition or extinction of some of the species. Now, the word niche, maybe I've come across it or not. The word niche simply means the role an organism plays in an ecosystem. When you talk of the role, we have one major role of organisms in an ecosystem. They simply act as a conduit for matter and for energy. These are medium through which energy and matter flows. So they are just conduits. Those organisms. That's why we talk of trophic level. So niche, the specific role an organism plays in an ecosystem. That role, the role is going to play. The role of an organism could be either acting as a producer, primary producer, secondary consumer, primary consumer, secondary consumer, or tertiary consumer. That is the role. Then that one becomes their niche. So a niche could be an equivalent of the trophic band in which the organism exists. So that is all about interspecific competition. So we should be able to remember that interspecific competition is slightly dangerous than intra. Inter leads to extinction. So in our part B, intra, we have two types of competition. First, interspecific competition. Second, intraspecific competition. It is supposed to be intraspecific. Intraspecific competition. So intra means we have organisms of the same species, but they are competing among themselves. So this is competition. This is competition among organisms of the same species. Of the same species. Now, for example, if you place rats in a cage and give them all the requirements, it will reach a time, one, there will be a decrease in food supply, which means a resource has gone down. And then the other thing, they are reproducing. If they are going to stay in that cage for a longer time, they are reproducing, they are increasing in number. So increase in population and reduced supply of resources can lead to competition. So we give an example, e.g., if rats are placed in the same cage, with all resources or with required resources, for months, for several months, there'll be an intra-specific competition. But now, competition of this kind, it cannot lead to all the rats dying, because the only thing that exists, the only animal or organism that is in this cage is a rat. So the worst that it can happen, or that can happen in this cage, is simply decrease in population. Population will decrease. It will decrease, but it cannot hit zero unless the resources are completely depleted, they are left to starve for a longer time, then there'll be that. So intraspecific competition is less stiff as compared to interspecific competition. So as we have already noted, that stiff competition can result from due to two factors. Due to organisms of different species, one, and then two, when the two different organisms of different species are having the same ecological role. They are of the same niche, they occupy the same niche. Then we have exclusive competition that will lead to extinction. So now we can illustrate intraspecific competition using this kind of a curve, where there will be normal growth, but at a point, now the population starts to decrease. So in our case, if we have time, and this time, maybe if we are looking at rats, we use months. And then we have population density. Then what will happen? There will be normal growth, slow growth at first because there are fewer number of organisms, and then they are not well adapted to the ecosystem or their habitat. But now they'll have to increase faster, exponential growth, log phase, a phase of slow growth, and then it becomes constant. It becomes constant at that point. So this is the kind of growth that will happen in case of intra-specific competition. There'll be normal growth like that, but now competition will start happening at that point. Why? Because of limited supply of resources like space, breeding sites, mates, and several other factors. That's why it is a plateau phase, constant. So with this, we want to emphasize that competition to happen, we must have organisms demanding the same resources, but within the same ecosystem, so that now we have what you are calling competition. But it's a very important phenomenon in an ecosystem, because as we have already found out, if we are going to have organism that has low competitive abilities, for instance, low fertility, it cannot be able to compete. Having low fertility is a bad characteristic or a bad feature. So in the process, it's going to be eliminated. So in essence, competition brings about elimination of bad qualities from the population. So let us stop there, and we shall continue in our next lesson to look at some of the adaptation of the competing organisms. So if you have a question, maybe a remark, a statement to put across to us, you can always do it through the email address that we provide. Thank you.